Hello Algebra 2 and welcome to this quiz solution video for the Chapter 3 and 4 quiz. Before you started this quiz, I advised all of you to be very careful with problems 1, 2, and 6 and remember to identify any excluded values or be careful of finding extraneous solutions. And from grading your quizzes, I can tell that there's a lot of confusion on this front. So I thought I would commence this video with some help in identifying where you can predict that you're going to have issues. So issue number 1, these are things just to look out for in math. If you have a problem involving a fraction, a number divided by a number, one thing we know about fractions is something about the denominator. The denominator cannot equal 0. So whenever you have a fraction, if you have a variable in the fraction, say, x plus 3 over x minus 7, well, I have a variable, an x, in the denominator. I know I cannot divide by 0, and my denominator cannot be 0, so that means that 7 is one value that x just can't be, because as soon as x is 7, then we've got, 10 divided by 0, which makes no sense. So whenever you see a problem involving a fraction, be careful and start thinking, gosh, maybe I have an excluded value, something x can't be. I'm looking off to the side here and I see problem B, right? B. It's got a variable in the denominator, and we know we cannot have that be 0. So if y is 0, then what we have is 6 times 0 minus 1 divided by 0 plus 2. It's negative 1 divided by 0, which makes no sense. 0 is an excluded value. So whenever you see a fraction, immediately think, gosh, maybe I have excluded values. Other trouble spots. Whenever you see absolute values. Whenever you see absolute values, you know that they cannot equal negative numbers. So that's a problem, and that's just something to be aware of whenever you see a problem involving an absolute value. I look at D. I've got a problem involving an absolute value. I want to be careful. Square roots. Whenever you see square roots, we know that the square root of a negative number cannot happen. So that's a problem. And also squaring things, whenever you square roots, whenever you square a square root, you are automatically making it a positive solution. So this is something to be aware of. Whenever you're squaring square roots, you could, if I said the square root of x equals x plus 3 or something like that, and I squared both sides, I get an x equals x squared plus 3. Well, and this isn't going to be a great answer, but if I were to solve this problem here is going to have 2 solutions. And you should check, whenever you do this, you should check to make sure that both of your solutions actually make this equation true, because maybe one of your solutions is negative, and we can't have a negative inside a square root. So these are just 3 trouble spots whenever you see fractions, absolute values, and square roots. You should be very concerned about whether there are excluded values or extraneous solutions. That said, let's take a look at problem number 1. Problem number 1, do you see a fraction? Do you see an absolute value, or do you see a square root in this? No. So if you're thinking about this, looking at this problem, are there any things that y simply cannot be? Are you breaking any rules? Well, certainly y is going to have an answer, but we're not taking a square root of a negative, we're not taking an absolute value, and we're not dividing by anything. So there are no excluded values in a problem like this. What we do have, though, is 3 times a squared thing plus 8 equals 83. And just looking at this, I can think that there are probably 2 numbers that could be in there. Either a positive or a negative thing squared will still get me a positive value. So I should come up with 2 answers. Well, now let's come up with those 2 answers. We had a y minus 1 in here. The very first thing we should probably do is isolate that y minus 1. And so I'm going to start by subtracting 8 from each side. Oh, by the way, these problems were worth 4 points each. So I have 3 times some stuff that's squared equals 75. I really want to know what this stuff is, what y could be. And so maybe what I'll do is I'll divide both sides by 3. and I get some stuff squared has to equal 25. Well, there are two numbers that could be inside this, these parentheses, and those two numbers are positive or negative 5. And so when I'm writing my next line of work to get my solution, I should say this means y minus 1 could equal 5, or y minus 1 could equal negative 5. And if we add 1 to each side here, we get y could equal 6. If I add 1 here, I get y could equal negative 4. If you wanted, you could check both of these numbers, but it doesn't matter whether you plug in a 6 here or a negative 4. Either way you slice it, the inside of this will be 5. You're going to square it, you'll get 25. You multiply by 3, 75, plus 8, 83. They both work. Two answers whenever you have a quadratic, because quadratics have x squared, and those problems have two solutions, often. Taking a look at part B. You assess this problem. Does it have a fraction or absolute values or a square root? And oh my gosh, it's got a fraction. So right off the bat, we have an excluded value. We know the denominator cannot be 0. So the first thing we might want to write off to the side is we know that y cannot be 0, because if y is 0, this problem does not make sense. To go from here, there are multiple ways to go about solving this problem, and I'll show you several different ways. So some people decided, oh gosh, I'm going to get rid of the fraction right away. Plus 2 equals 0. And so what they did is they said, I'm going to multiply by 6y and multiply by 6y. That's all fine and good, but when you're multiplying by 6y, you're multiplying both sides of an equation by that value. And 6y times 0 is definitely 0 over here. 6y times something divided by 6y is the something. So this is 6y minus 1, this first part. So you're multiplying 6y by this first term, but then you're also multiplying 6y by 2. You have to use the distributive property, and that is 12y. And from here, it is an algebra 1 problem. We get 18y minus 1 equals 0. Not a pretty answer, but we can add 1 to each side and get 18y equals 1, and y must equal 1/18. Okay, so that is one way to go about solving this problem. Some people solved it differently. Oh, by the way, and I guess we don't need to say that y is not 0. I guess we don't need to say that y is not 0, because y equals 1/18 is the solution to this problem, and this solution is not 0. So we've solved the problem, y equals 1/18. Now, if we got an answer, we did all this work and we got the answer y equals 0, well, that's a problem, because we know up here y cannot be 0. So then we'd have a no solution. So that was a little bit mean. So really all you need to do is put this y equals 1/18. Now, some people solved this problem a little bit differently. Some people said, all right, I have 6y minus 1 over 6y plus 2 equals 0. Some people started by subtracting 2 from each side. That's a fine thing to do. So I'd have 6y minus 1 divided by 6y equals negative 2. And then those people put that over 1 and multiply both sides by 6y, or cross-multiply it, as the case may be. So we multiply by 6y, multiply by 6y, and here on the left side our 6y's cancel. We get 6y minus 1 equals negative 12y. And now we're back to an algebra 1 problem. I'd subtract 6y from each side. I get negative 1 equals negative 18y. Hi. And dividing both sides by negative 18, I get the same answer. Y equals 1 over 18, which is the solution. So we don't need any excluded values, because we have an answer for y that is not an excluded value. Fantastic. Let's move on. Number C. Number C. So looking at number C, I see a square root. We just better make sure we don't get an answer that makes the inside of our square root negative. And we also should check our answer and make sure that when we plug it in, we do get a -7 for an answer. So again, I saw multiple ways to go about solving this problem. Multiple ways to go about solving it, and so I'm going to show you a couple of things that I saw. Here's the very first thing I saw. I saw people wanting to square both sides. -1 minus 2x equals -7. And that's a fine thing to do. My question is, the left side here is a negative something. It's a negative number. Equals -7. What happens when you square a negative number? When you put this thing in parentheses and square it? And gall dang it, it becomes positive. If you square a negative thing, it becomes positive. So squaring both sides is a more than fine thing to do. But when you square a negative thing, it becomes a positive thing. And so it becomes 1 minus 2x. I can't tell you how many people told me this was -1 plus 2x. It doesn't matter what the number is, negative square root of 37. If you take that and square it, it's negative square root of 37 times negative square root of 37, which is still 37. The thing inside does not change. The term inside does not change. So this is just 1 minus 2x when you square it. If you square -7, you get positive 49. At this point, we're down to an algebra 1 problem again. I get -2x equals -48. And if I divide both sides by -2, I get x equals 24. You could check it and see what happens if we plug in, oops, did I screw up? Yes, I did. I did. Oops. That is positive 48. And that makes this a -24. Now we're happy. Okay, you could check that -24 by plugging it into the original problem. If I plug -24 in here for x, what I get is negative square root of 1 minus 2 times -24. Well, that's negative square root of 1 plus 48, which is negative square root of 49, which is -7. So it checks out. So that was one way to go about solving this problem. Here is what I consider a much more straightforward way of going about solving this problem. Negative square root of 1 minus 2x equals -7. Not straightforward, but it just makes it a little bit clearer. I just divide both sides by -1 and make this the positive 1 of 1 minus 2x equals positive 7. Then go ahead and square both sides. I square both sides. I get 1 minus 2x equals 49. I'm exactly where we were right here. And so I'd go through the same steps and get x must equal -24. We checked the answer. We know it works. We don't have any excluded values because we got an answer, -24, and it works. So we're done with part C. Moving on to part D. Oh my gosh, I spy absolute values. So right off the bat, I want to make sure that I don't end up with an answer for x that makes, well, and actually let's look at this problem. Could we end up with any answer for x that makes this problem impossible? Utterly impossible. Well, this over here is an absolute value, which is a positive thing. And we're saying this equals +5. So I don't think we have any excluded values or anything that we really need to be too cautious of. But I can tell you this. We are going to have two answers. Because think about it. If I told you the absolute value of some mystery number is 5, you would tell me that that mystery number either could be +5 or -5. So you should write two equations. I saw so many people first, here's a common thing that I saw. Common mistake. I watched people subtract 1 and say -2x equals 4. And then they wrote -2x equals 4 or -2x equals -4. Let's think about it. What we're saying is that this thing here could be 4. Well, 4 plus 1 gets us 5, so that works. Or this thing here could be -4. But -4 plus 1 is not -5. It would be or positive 5, it would be 3. So this is a problem. This thing here is a big problem. No, no. You need to think of absolute value problems as whatever is inside could be 5 or negative 5. And you should write your equations to say exactly that. Group. There you go. So to write those equations, I would say this means either negative 2x plus 1 could be 5, or negative 2x plus 1 could be negative 5. And then we can solve them. I subtract 1, I get negative 2x could equal 4. Dividing by negative 2, I get x could be negative 2, apparently. We'll check that in a second. Make sure it works. Here, if I subtract 1, I get negative 2x equals negative 6, in which case x equals, divided by negative 2, I get x equals positive 3. We'll check that and make sure it works. Now let's go and check these things. If x is negative 2, what we have is negative 2 times negative 2, which is 4, plus 1, well, that's going to check out. It's going to be 5. If x is 3, we get negative 2 times 3, which is negative 6, plus 1. Well, that's going to be negative 5, and when we take an absolute value, we get 5. That checks out. We have our two answers. We're good to go. Let's move on to problem number 2. Group. So actually, in this entire problem, there were no excluded values. In problem 1, no excluded values and no extraneous solutions. An extraneous solution is where you solve a problem, by the way, is where you solve a problem and you get an answer, but your answer just doesn't work. We checked all of our answers. Our answers work. Let's check in with number 2. Okay, so for part A, you got no points if you knew to set them equal, because that's an Algebra 1 skill that has to be in your bag by now. So most people knew to set these two equations equal. Again, I saw several different ways of solving this thing, and I think I'm just going to go with the most, well, what the heck. I'll show you a lot of things that I saw. Here's something I saw. This is not the correct, not an efficient way to solve this at all. Some people subtracted 2x and added 2, subtracted 2x and added 2, and they wrote 1/3 x squared minus 2x plus 3 equals 0. And then they tried to factor this thing. And I'm going to pause and go see what sorts of answers I got. So I pulled up an example of pretty much a classic student response. This here's somebody who got to this point. Looks like they forgot the x right there. But they got to this point, the same point that I got to, and then they tried to factor this thing. The problem with trying to factor this thing is it's really hard to factor when you have a fraction in front of an x squared. And if you were to multiply this out, you'd have 1/3 x times x. You'd have 1/3 x squared. 1/3 of x times 1, so that's 1/3 of x. And then negative 3 times x, so minus 3x. Hello, you did not get two x's in the middle. You have 1/3 and negative 3. You have negative 2 and 2/3 x's in the middle. So it's really, really challenging to try to factor something like this. So that was one common mistake that I saw on this problem. Just as a heads up, here's another thing I saw. I saw people trying to randomly take the square root of both sides to get rid of that x squared there. If we do not know at this point that when you have an x squared in a problem that you have to set it equal to 0 and factor, then I am automatically docking all of your points. I don't care where you went from there. That is a mistake that I'm not gonna tolerate anymore. There are 2 or 3 mistakes I'm not tolerating anymore, and this is one of them. We'll go over the other mistake in the next problem. All right, so because this is so hard to factor, I strongly recommend you do this. Since this equation equals 0, what you could do is multiply both sides by any number in the world, and it will still equal 0. And I'm going to say the number 3 is the best number in the world, because 3 times 1/3 is 1x squared, minus 6x plus 9 equals 0. Now we haven't broken any laws of math, but we made this problem one heck of a lot easier to factor. X, x, and minus 3 and minus 3. So we have an answer, a solution, x equals 3. This is a system of equations involving x's and y's, so you should go back and find the y value. If x is 3, y is 2 times that 3, which is 6 minus 2, so that's 4. So we think the solution must be 3 comma 4. I just checked it in this equation because we used the equation to get the 4. Let's check it in the other equation and just make sure it works. So I'd put in 4 has to equal 1/3 of 3 squared, 9, plus 1. Right? Yep. So 4 equals 1/3 of 9, which is 3 plus 1. It checks out. So this is my solution. Let's take a look at part B. Part B says, solve this system of equations. And again, it's always good to think about these things graphically. In the last problem, in part A, we had a parabola crossing a line. A parabola crossing a line. And it is a squished parabola moved up 1. So we've got a y-intercept of 1, and it is compressed. And we have a line, y equals 2x minus 2, so here it is. And it sure looks like if we have a slope of 2, well, these functions might not cross at all, or they might cross exactly one time. Turns out that they do cross exactly one time. We found that. Taking a look at the next problem, part B, and thinking about this graphically, I've got a square root crossing a line. Square roots look like, oh, and it's shifted forward 3. So it's shifted forward 3, like so. And a line x minus 5. 1, 2, 3, 4, 5, with a slope of 1. I'm just going to use my Spidey powers and guess that these two graphs cross one time. There's one solution based on my sketch of a graph. Now, let's go about finding that solution. So, if what you did is you wrote, that means the square root of x minus 3 must equal x minus 5. That is a good first step. And then I saw so many people square both sides, which I think is a fine idea. If you square both sides, you're squaring a square root. Those two functions are inverses, and so you get the inside. If at this juncture you squared x minus 5 and wrote x squared plus 25, I should have taken off all 4 of your points. I'm pretty sure I took off 3, and from now on I'll be taking off all your points for a rookie error like this. If you said it's x squared minus 25, I should, again, take off all your points, minus 4, because we know at this point in Algebra 2, that when you square x minus 5, that this is not the same thing as squaring the x and squaring the 5. That when you square x minus 5, you're multiplying a different number, x minus 5, by itself. And if you were to multiply that out, x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. So this thing does multiply out to x minus 3 equals x squared minus 10x plus 25. From here, again, we have a quadratic, and so we know to set it equal to 0. So I'm going to subtract x and add 3 to each side. I get 0 equals x squared minus 11x plus 28. Hopefully this factors. I believe it does. That factors to x minus 4 and x minus 7 equals 0. And so we have two answers. X must equal 4 or 7. But hey, remember what I said a while ago when I thought about the sketch of this thing and it looked like they only crossed one time? Well, it looks like we're about to be headed for an extraneous solution. Extraneous means extra. Extraneous. Extraneous means extra. I said these graphs would cross one time, and I just got two answers. So one of these numbers, one of these answers does not make this system true. Let's test, does not make this equation true. This square root of x minus 3 equals x minus 5. So I could test, let's say we try, say, 4. If I test 4, I get the square root of 4 minus 3. Does that equal 4 minus 5? Well, this is the square root of 1. Does that equal negative 1? Aha! I found it. That one doesn't work. This is extraneous. I'll abbreviate that. We should, just for kicks, test the 7. I get the square root of 7 minus 3. That's the square root of 4, which is 2. Does that equal 7 minus 5, which is 2? All right, happy day. The 7 works. Since it's a system of equations, we're looking for a point on the graph where these two functions cross. You should find the y value. We found an x is 7. To find a y value, 7 minus 5 is 2. So y could be 2, is 2. So these two graphs cross at 7, 2. Moving along to number 3. Find the equation of the lines described below. All right. A. Finding the equation of a line that passes through a point. Again, I will show you 2 ways how to do this. You may choose either way. If you chose the y equals mx plus b way, that's a fine way to go. We have an x and a y and an x and a y. So if I substitute those values in, my first equation would become 1 equals m times the x plus b. Not 6, b. Oops. There, b. And then my second equation would become negative 7 equals m times x plus b. As these two equations are written, nothing eliminates. We have a positive b and a positive b. These do not eliminate. But what you could do is you could take the entire one of your two equations and multiply both sides by negative 1. And so your first equation is 1 equals 6m plus b. And the bottom equation is positive 7, equals positive 10m minus b. And now when you add up everything on the left side, you get 16m. And when you add up everything on the right side, you get 8. Dividing by 16, we get a slope, m, which is 1/2. So, yay, we have a slope. Once you have that slope, you can put it into your equation, y equals 1/2 x plus b, and we can solve to find a y-intercept. I'll plug in that point right there. That would mean 6, I lied, that would be 1. 1 must equal 1/2 times 6 plus b. 1 must equal 1/2 of 6 is 3 plus b, so I get a b value of negative 2. Final equation, y equals 1/2 x minus 2. That is one way to find the equation of a line between 2 points. Here is another way. If we take a look at these 2 points, and the points are 1, well, let's see, my y values are 1 and negative 7, x values are 6 and negative 10. One thing we know is that the slope is the change in y's, which is called the rise, over the change in x's, which is called the run. So the change in the y's would be from 1 to negative 7. If you're thinking about this on the number line, here's 0, here's 1, here's negative 7. That is a distance of backward 8, or negative 8. And if I take a look at my x's, the change in my x's, I went from 6 to negative 10. Well, 6 is over here, and negative 10 is over here, and that is a distance of backward 16. So my rise over run is negative 8 over negative 16, which is positive 1/2. Again, we'd write y equals 1/2 x plus b, and pick a point, plug it in, and solve for the b value. Just to be different, I'll plug in the second point. Negative 7 has to be 1/2 of negative 10 plus some mystery value. So negative 7 has to be negative 5 plus a mystery value. I solve for this mystery value by looking at it. B must be negative 2. So y equals 1/2 x minus 2. The end. Let's take a look at part B. Part B says find the equation of a line that is perpendicular to this line. Well, if lines are perpendicular, perpendicular lines definitely have different signs, because if one is heading uphill, the other's heading downhill, or if one is heading down, the other's heading up. And they have different slopes. And I'm hoping that at this point in your math career, you know that if one of them has a slope of negative 2/3, then the reciprocal slope, or the perpendicular line, would have a reciprocal slope of positive 3/2. So you just had to say y equals positive 3/2 x plus some mystery y-intercept b. If you were a clever cookie, you looked at this number and realized I gave you the y-intercept, it's 5. Or if you wanted to plug it in, you could. xy, 5 equals 3/2 times 0 plus b. 3/2 times 0 is 0, so my b must equal 5. Okay, found the y-intercept. Boom. There it is. It's 5. Yay, us. Taking a look at number 4. Solve each inequality and graph the solution on a number line. Okay, well, we were given a little number line down here, and we were given this inequality. What I recommend you do when you're solving inequalities is first find some boundary points. First, find out if you can solve the equality. What makes x squared plus 2x minus 8 equal 0? Well, if I wanted to find out where this equaled 0, I'd factor it. Xx, probably a positive 4 and a negative 2. And so this equals 0 when x equals negative 4 or when x equals 2. Now, red alert, if you plug in either of these values to this inequality, it will not make it true. If I plug 2 in there, I get 2 squared plus 2 times 2 minus 8. Is that less than 0? Well, this is 4 plus 4 minus 8. Well, that's 0. Is that less than 0? No, it doesn't make it work. Should make sense it doesn't make it work, because we just got done solving an equality, not an inequality. So all I know is that something is changing at negative 4 and something is changing at 2. If I wanted to find out where this function is less than 0, there are a couple of 3 ways to go about doing that. Method number 1, test some points. Test, say, 0. Does 0 make this inequality less than 0? Well, I get 0 squared plus 2 times 0 minus 8. That's definitely less than 0, so 0 works. So my hunch is that every value in between negative 4 and 2 works. Alternatively, you can test 3 and verify that it doesn't work. 3 squared plus 2 times 3 minus 8. Is that less than 0? Well, that's 9 plus 6 minus 8. That's definitely a positive number, and so it's not less than 0. So this is a fail. You could similarly try negative 5. It will also fail. So that is one way to go about finding where on the number line your solutions are. Another way to do this is to think about the graph. This thing here is a parabola, and we solved for x-intercepts. So if I'm graphing this thing, I'd have an x-intercept at negative 4, an x-intercept at 2, I'd have a parabola. And what we're asking is, where is this parabola less than 0? Less than 0. Well, that would be all in here. So for all values between negative 4 and 2. I've already given you a number line solution here, right here. However, we haven't written a solution to this problem. X has to be smaller than 2 and greater than negative 4. So this is the inequality solution, and this is the number line solution. And you've got to have both. Let's take a look at part B. Part B says, solve this, baby, and graph solutions on a number line. Well, again, this is an inequality. I recommend the way to go is to start by solving an equality. What makes 3x minus 3 absolute value equal 9? Well, You're solving absolute values, and so I would say, okay, think about what's on the inside. What's inside that blue box can be one of two numbers. It can be positive 9 or negative 9. So I'd write two equations. 3x minus 3 could equal positive 9, or 3x minus 3 could equal negative 9. And we can solve them separately. And again, I'm only solving for what makes this equal. So I add 3, I get 3x equals 12. X is 4. So 4 makes this an equality. Adding 3, I get 3x equals negative 6. So x equals negative 2. So negative 2 also makes this an equality. Since we have an or equal to option here, I know that 4 and negative 2 are part of my solutions. So this is part of the solution, and this is part of the solution. But I'm not really sure where all the rest of the solutions are. So we should test some sides of 4 and negative 2. So suppose I test, say, 0 is always a fun one to test. If x is 0, well, if x is 0, this inequality becomes 3 times 0 minus 3. Absolute value, is that bigger than or equal to 9? Well, that's the absolute value of negative 3. Is that bigger than or equal to 9? No siree. 0 is a fail. 0 does not work. Just for kicks, let's test 5. Test 5. Does 3 times 5 minus 3? 3 times 5 is 15, and 15 minus 3 is 12. So does the absolute value of 12, is that greater than 9? This is success. Yay! So I know that numbers, values over here appear to work. And I could also test, say, negative 4. Just negative 4 right there. If x is negative 4, I get 3 times negative 4 minus 3. That's negative 12 minus 3, and that's negative 15. Is the absolute value of that bigger than 9? You betcha it is. So it also appears that values over here make this true. You could also think of this graphically. It's a little bit tougher with absolute values, but what this is saying is some absolute value graph has to be greater than or equal to 9. So some v graph has to be greater than or equal to the line where y is 9. And if you think about this v graph where it's greater than 9, it's on this side and on this side. I think it's a little bit easier to do a number line check, but and you still have to algebraically solve for boundary points or breakpoints. Notice I have not written an answer yet. I've only graphed things on the number line. When you have values, we're saying that x could be greater than 4, or x could be less than or equal to negative 2, but it can't be both, so you can't write a single inequality statement. As a matter of fact, to do this correctly, you should put the word or in there. So x could be greater than or equal to 4, or x could be less than or equal to negative 2. And this is your algebraic solution. Let's take a look at number 5. Number 5 said graph some inequalities or systems. So A was worth only 3 points because it was just make a graph. It's an absolute value. It's shifted back 3 and down 2. So you went back 3 and down 2. It's got a slope of 1. So we graphed up that way and up that way, and you could have picked this right out of your toolkit. So there's the graph of the absolute value. I might have given you 1 point for graphing the absolute value correctly, because the other 2 points were all about shading, because this says where are the y values greater than or equal to the absolute value graph. Well, you could always test a point. Suppose I test 0, 0. Does that make this inequality true? Is 0 greater than or equal to 0 plus 3 absolute value minus 2? Is 0 greater than or equal to 3 minus 2? Well, this is a fail. Oh, there, we'll make it a little frowny face. So 0, 0 is a fail, which means probably the other side of the absolute value, say values inside the absolute value, inside the v, make it true. Just for kicks, I'll test the point I just identified, which is negative 3, 0. So 0 has to be greater than or equal to negative 3 plus 3 minus 2. 0 would have to be greater than or equal to 0 minus 2. That is true. Whoops, true. You get a smiley face, which means all values inside here work. So we should shade them. There we go. Let's take a look at number B. And number B was worth 6 points, 3 for each graph, and correct shading on each graph. I'll start with the easy one. This is a line. It has a y-intercept of 2 and a slope of rise 3, run 4, or fall 3, back up 4. So there's the line. Oops, that's a lousy line. There. Okay. This says where the y value is less than or equal to the line. So my hunch is that that means below, just in case if you wanted to test a point 0, 0, you could test it on that equation. I'd say my equation would become 0 has to be less than or equal to 3/4 of 0 plus 2. So 0 would have to be less than or equal to 2, which is true. So I'm definitely shading below the line. Okay, my upper graph here is a parabola. So this is a parabola, and it's not in graphing form. So there are a couple of ways that you could go about graphing this thing. One is to put it in graphing form. You could take this equation and take the equation y equals x squared minus 2x minus 3, and you could make a perfect square. So I have x squared minus 2x, and I want this to be a perfect square with a minus 3 at the end, well, with something at the end. So if you think about what you really need to make it perfect, you need a positive 1. And just in case you forgot how to do that, I said I have an x squared. Since we have 2 negative x's here, I must have 1 negative x in each edge. So x minus 1 and x minus 1. And I need a positive 1 right there to finish my square. So I need a positive 1. We can't just go namby-pamby adding 1 whenever we feel like it, so we would also subtract 1. And so this would be x minus 1 squared minus 4. So this was one way to go about graphing this thing. That's forward 1 and down 4. Graph and point, and up 5. So that was one way to do it. Another way to go about graphing this parabola is just to find x-intercepts. X and y-intercepts would be probably enough. So if I took this equation, minus 3, and just factored it, x minus 3 and plus 1, this has x-intercepts at positive 3 or negative 1. So, oh, here they are, positive 3 and negative 1. And looking at my original equation, it has a y-intercept of negative 3. I can use some symmetry to plot the other point and then just deduce that that must be my vertex. This is a dashed line because it's strictly less than. Now we need to figure out whether the shading is on the inside or the outside of the parabola. And so I'm thinking we could test a point. Let's test, say, 0, 0. Does 0, 0 make this parabolic equation true? So 0 has to be less than 0 squared minus 2 times 0 minus 3. So 0 would have to be less than negative 3. This is not true. 0 is not smaller than negative 3, so this point here is a fail, which means the points on the outside of the parabola must be true. So points on the outside of the parabola must work. We're only looking for where these two functions overlap. And so I would go back and I would erase my shading from up above, and I would erase the blue only shading from the inside, because it is both below the line and outside the parabola. That includes all solutions to this system. Okay, taking a look at number 6. Number 6. 6A was worth 6 points. I gave you 4 points for doing the algebra correctly, and I gave you another 2 points for identifying all possible excluded values because, oh my gosh, there are fractions. And so one thing we know about fractions is the denominator cannot equal 0 because then we just have a nonsense problem. So you had to factor these things. Taking a look at the top of this fraction, let's see, I'm thinking it was 4x and an x, 4x and x. To get to 11, if I took my 4 and multiplied it by 3, then I know we got to 12x right there. And here, 3 times 1 gets me 1x. These two will combine to negative 11x if the 12 is negative and the 1 is positive. So the 12 is negative and the 1 is positive. First problem is factored. Next problem, denominator. So we have parentheses, 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 parentheses. A 5x and an x. Things that multiply to 10. Well, I'm thinking 5 and 2, and if we put the 5 there, we got very close to that 23. We're at 25x. And this makes 2x. So sure enough, that can be negative 23 if the 25 is negative, and the 2 is positive. All right, first fraction factored. And we automatically have 2 excluded values. But let's take a look at our next fraction. Times 5x plus 2. Mercy, we don't have to factor that. The bottom of this thing factors quite nicely. X, things that multiply 27, 9 and 3. Minus 3 minus 9. That adds to 12 in the middle. Times. Oh, things that multiply to 36. There are a lot of choices. It turns out that 9 times 4 multiplies to 36 and adds to 13. 4x plus 1. So everything is all factored up and ready to go. I would, at this point, write some excluded values because we know we cannot divide by 0. So here, my excluded value would be negative 2/5. Negative 2/5 is one of them. 5 is definitely excluded value because then I'd be dividing by 0 there. 3 and 9 are a couple of others, so 3 and 9. And then to make this 0, x would have to be negative 1/4. That said, we've written our excluded values. Let's go cancel things. So let's see. This dude cancels with this dude. This gal cancels with this gal. This thing cancels with that thing. We got a 9 there and a 9 there, and that's all she wrote. So what our answer is this thing equals x minus 4 over x minus 5, provided x isn't any of these things, because those wouldn't make any sense. Let's take a look at B. Oops. B was also worth 6 points. Again, you got 4 points for doing all the factoring properly, and another 2 points for writing all the excluded values. So, taking a look at the top of this thing here does factor to x plus 3 and x minus 3. And I want to point out x squared minus 9 factors, because when you multiply this out, you're going to have a positive 3 times a negative 3, and those do make negative 9. Now, the middle term vanishes because we have plus and minus the same thing. This is positive 3x, and this is negative 3x, and they cancel each other out, so there's no term in the middle. I want to underscore that difference when we get to x squared minus 4, because x squared plus 4, because x squared plus 4 is a different beast. All right, factoring the denominator of this first fraction. We have an x plus 3 and an x plus 3. We are dividing fractions. We'll think about dividing later. The top of the second fraction does factor to x minus 3 and x plus 2. The denominator, this thing right here, x squared plus 4, does not factor. Because if you tried to say it's x plus 2 times x minus 2, well, when you multiplied that out, you'd get x squared minus 4, not x squared plus 4. If you said it was x squared plus 2 times x squared plus 2, or x plus 2 times x plus 2, you would get x squared plus 2x plus another 2x plus 4. So you got your x squared and you got your plus 4, but you ended up with an extra 4x in the middle. This thing does not factor. It's just x squared plus 4. That's it. No se puede factorar. Uh-oh, I wonder how the video is going to translate that. Spanish speak. Whoops. Here we go. Alrighty. So, now, I think I'm ready to write some excluded values, though, because we cannot divide by 0. So, x cannot be -3 or -3, but we already addressed that. And you could think about how that's going to be 0. Could x squared plus 4 ever equal 0? And it can't, because that would mean x squared would have to equal -4, and that doesn't have a solution. So we don't have to worry about this denominator being 0. But definitely -3 is out, so x cannot be -3. Now that we're dividing fractions, let's rewrite the first. And take the reciprocal of our second fraction, changing the sign to multiplication. Oh my gosh, we have just created 2 more excluded values. X can't be +3 and x can't be -2. So let's write them down. +3 and -2. But now we can try to reduce some of these things. Let's see. This guy and that guy cancels. We have an x -3 and an x -3. And that's all she wrote. So let's write an answer. Our answer would be x squared plus 4 on the top. On the bottom, x plus 3 and x plus 2, comma, with the excluded values that x cannot be positive or -3 or -2. All right, that was part B. Moving on to part C. Part C says add some fractions. Something I want to point out to a lot of people who ended up doing math and then telling me what x equals at the end of this problem. This thing here is not an equation. It is an expression. It's 2 values being added or subtracted. So you have a 6 minus a fraction. So if I gave you the problem, well, no matter what, this is not an equation. You can't solve and tell me what x equals. So for future notice, if you solve an expression, if you invent an equal sign in a problem and solve for something that cannot be solved for, again, I'm not going to check your work. I'm just going to dock all your points. Because we should know at this point that this is not an equation to be solved. All we're doing is adding a couple of fractions. In order to add fractions, you must have a common denominator. The current denominator under 6 is a 1. So if you wanted to have, say, an x plus 1 in the denominator, what you would need to do is take this 6 and multiply by a very fancy version of 1, like x plus 1 over x plus 1, minus 3 over x plus 1. Keep in mind, we have fractions, so we do have some excluded values. We know that no matter what, when we add these things, x cannot be -1, because if x is -1, this problem makes no sense. We get 6 minus 3 over 0, and that doesn't equal anything. That equals a very unhappy face. So we can, oops, what am I doing? Undo, undo, undo. I just made a rookie mistake. I did what you guys do. I put that x plus 1 there for a reason, and the reason is so that my denominators are the same. The numerator of my first fraction is 6x plus 6 over x plus 1 minus 3 over x plus 1. Because we have a common denominator, we can combine the numerators. And so it's 6x plus 6 minus 3, so plus 3 over x plus 1. Some people tried to factor and reduce. The top does factor. A 3 can come out of the top, but in order to get a 6x, you'd have to multiply that by 2x plus 1 divided by x plus 1, and nothing reduces. And so you could have left this as your answer, But notice I left a little spot over there because it equals that only as long as x does not equal -1. You needed that excluded value. Let's take a look at part D. For part D, again, we're adding or subtracting fractions. And again, since we have fractions, we're going to have excluded values. We're going to have some things that the denominator simply can't be. Some values for x that the denominator can't be. We have a 5 over x. Right off the bat, I'm thinking 0. X can't be 0, because then you'd have 5 over 0 minus 10 over 0. So we're trying to add these fractions. We need a common denominator. Just like if you're adding 5 over 6 and 13 over 12, you don't need to multiply 6 and 12 to get a common denominator. What you might notice is that all you really need to do is multiply that 6 by 2. And then you'd multiply by 2 over 2, and you'd get 10 twelfths plus 13 twelfths. And the way to recognize that you could have a lower common denominator than 6 times 12, than 72, is by noticing that you can factor 12. 12 is 6 times 2, so all we needed was a times 2 there. Using that same logic, if you factor x squared minus 2, then this problem becomes 5 over x minus 10 over factoring x squared minus 2, that's x, times x minus 2. So in order to get a common denominator, all we really need in this denominator is an x minus 2. So I'm going to multiply by a very fancy version of 1, x minus 2 over x minus 2. Oh my gosh, we just identified the other excluded value, 2. X can't be 2. So if x is 0 or if x is 2, this problem makes no sense. So now what we have is 5x minus 10 over x times x minus 2. And we're subtracting 10 over x times x minus 2. We can now combine the numerators. 5x minus 10 is 5x minus 20 over x times x minus 2. Some people tried to factor this from here. It's true you could factor this. This is the same thing as 5 times x minus 4 over x times x minus 2, but nothing cancels again. With the caveat that x cannot equal 0 or 2. There is my answer. Let's take a look at number 7. Our last one. Consider this system of equations and solve the system algebraically. We have an x squared plus y squared equals 25, and x squared equals y plus 5. I solved this thing this way so that it seemed like it would be a very direct substitution. What we can do is replace the x squared with y plus 5. And so we would say y plus 5 plus y squared equals 25. We have an equation involving a squared term, so I'm going to rearrange my terms, set it equal to 0, plus y plus 5 equals 25, and factor this thing. So if I subtract 25, we get y squared plus y minus 20 equals 0. We factor, we get y and positive 5 and negative 4. So my solutions are y must equal negative 5 or y could equal positive 4. So I have these two values for y. Let's go see if we can find some x's. Incidentally, well, we'll think about this graphically in a second. If y is negative 5, taking a look at this first equation, x squared must equal y plus 5. If y is negative 5, I get x squared has to equal negative 5 plus 5? Or x squared has to equal 0. Well, there's only one value for x that makes that true. When y is negative 5, x must equal 0. So that is one possible solution. Might want to check it in the other equation. We'll do that in a moment. If y is 4, and I take this equation, x squared equals y plus 5. If y is 4, I get that x squared has to equal 4 plus 5. Or 9, x squared equals 9. There are two values that make this equation true. And those two values for x are positive or negative 3, because either one of them, if you square it, you still get positive 9. So if y is 4, x could be positive or negative 3. So just in case you wanted to check these values, they all work in this equation. If you plug in 0 for x and negative 5 for y, you're going to get 25. If you plug in, it doesn't matter whether you plug in a positive or a negative 3 for x and a 4 for y. When you square it, you're going to get 9 plus 16. So everything works out. We have three solutions. One of them is 0, negative 5. The other is positive 3, 4. And the other is negative 3, 4. So those are the three solutions. Thinking about this thing graphically. Let me clean this whole mess up. There we go. So thinking about this problem graphically, what we have here is a circle, and a parabola. And a circle and parabola could cross, well, not at all the way I've drawn them, or they could cross one time, or they could cross 2 times, or they could cross 3 times, or 4 times. And we have the case where they cross 3 times, these three solutions. To show that, well, we buffed out our toolkits and graph them. Let's see, the circle has a center at 0, 0 and a radius of 5. So up 5, forward 5, down 5, back 5. Arc, little parabola, or not a parabola, little circle. If you're an overachiever, then you know that we graphed a circle of a radius 5 in your toolkit, and 3, 4, and 4, 3, and negative 3, 4, and negative 4, 3. All these points are perfectly, not that one, 3, negative 4, and there. All those points do fit perfectly on a parabola with a radius of 5. This thing here was not meant to deceive you. If you put it in y form, you would subtract 5 from each side, and you would get y equals x squared minus 5. It's just a regular parabola shifted down 5 units. 5. Over 1 up 1, back 1 up 1, over 2 up 4, back 2 up 4, over 3 up 9, back 3 up 9. But sure enough, our parabola and our function cross exactly where we said they did, or said they're supposed to. And it really helps to solve the system graphically to write the solutions. 3, 4 is one solution. Negative 3, 4 is another solution. And 0, negative 5 is our last solution. So hopefully this has been an illuminating video for at least one of you little Algebra 2 students.